Hello, everybody. Yeah, today I'm going to speak something very interesting. My previous session was about introduction based on product development, the importance of virtual simulation in product development. As discussed in my previous session, uh, there are certain important things which I actually wanted to, like make you all visualize the usage of virtual reality or virtual simulations in manufacturing. The manufacturing sector is rapidly evolving as a forefront of technological innovations with virtual reality, playing a key role in this transformation. And like you all know, virtual reality holds a potential to revolutionize every stage of production, from product development processes to employee training, from prototyping to optimization of production lines. So this also significantly helps in reducing cost, accelerating the processes involved in the product development, and increase the operational efficiency. So what I mean by operational efficiency is there is a huge process behind this product development. So you start from a certain concept, then the concept is put onto the paper. So that's the design part you do. So it can be in the form of drafting, it could be in the form of a 3D model, and then this is taken into a completely virtual platform where the simulations are mathematical, and based on these simulations, uh, they arrive at a conclusion, whether it's an optimized product or not. So there could be a lot of material wastage post production, I mean post manufacturing. So those iterations could be effectively done using the virtual simulation optimization, where the geometry is optimized, the material is optimized, and the material selection plays a major role here. You can keep replacing different materials, and then you can try to fit in the best material for that particular product. To enhance all these processes, the recent developments in generative design, generative AI, artificial intelligence, AI is playing a major role here, and that's what we call as generative AI, where a lot of optimization processes can be again optimized, and the time taken for the optimization can be drastically reduced. So there used to be a time when the virtual simulation processes took about 200 hours, say about 150 to 200 hours, which was later reduced to about 80 to 100 hours. And now, within the click of a button, using advanced GPU systems, we all are able to freeze upon a particular design of a product within minutes. And that's the wonder of artificial intelligence. And this is one more important thing which I wanted to specify today. And that's the reason, like my previous video, where I just gave a basic introduction for everybody to understand the importance of simulation. And here I'm going to give you a glimpse on what is artificial intelligence, the role of artificial intelligence in product design, and how it is done. So a typical uh, technology which you would have heard about is virtual reality. So the use of virtual reality in manufacturing not only enhances the efficiency and effectiveness of existing processes, but also offers the opportunity to create a new product or a production paradigm. So now today, like we have advanced prototyping capabilities. Like earlier, we had a restriction of getting into SLS stereolithography, SLS, SLA, and the very preliminary activities that happened in rapid prototyping were all very time consuming and very costly affair. So today, after AI, started effectively playing a significant role in every part of the industry. Okay, so 3D printing has become very important these days in every industry. So using the 3D printers, we are capable of generating prototypes. So that's again a virtual manufacturing process. We can call it as a virtual manufacturing process. So the entire prototype is developed, okay, with the help of a 3D printer using the desired material. It could be a PLA, it could be carbon fiber, it could be nylon, like it could be PEEK, Alten. So there are many materials with which we'll be able to develop a prototype, and this is significantly playing a role in every part of engineering. Wherever engineering is involved, it plays a major role, especially in the healthcare segment. A reconstruction of your skull, a reconstruction of your bones, designing and development of implants for dental purposes, and specifically for maxillofacial and orthodontics related, activities. So how virtual reality has transformed the production process? That is a very important thing that we need to realize over a period of time. So as you all know that we are moving from industrial revolution 4 to 5 and from 5 to 6. Okay, every industrial revolution had taken about 10 to 15 years, and now from 4 to 5 it is almost about 5 years, probably 5 years. And now from 5 to 6, you know it's happening within a couple of years, say maybe about 2 to 3 years. And that's the the beauty of technology, and that's the beauty of artificial intelligence, and how it plays a major role in enhancing the production process, the manufacturing processes. So we can also try to say that the design and prototyping, especially plays a major role in any of the product development process. And now this is a specific you know area where generative AI is playing a major role. So you can keep on doing design improvements. You can freeze the design, and there are n number of uh, parameters involved. Say there could be a thermal parameter, there could be a stress structural parameter, there could be a aerodynamic parameter, there could be an optical parameter, okay, and there could be an acoustic parameter. So different parameters in a single process can be like optimized, okay, which makes in fact the complete product development process or the cycle shorter. So what are the advantages? I just discussed about the quality. I just discussed about the significance of using simulations, using your finite element analysis, the computer engineering process, the computational fluid dynamic process. Okay, so there are a lot of mathematics involved behind that, behind these simulations, multi-body dynamics, your kinematics. So a good amount of engineering, good amount of technology domain is involved in this. Okay, now using artificial intelligence, your convolutional neural network or your machine learning processes, deep learning systems, it is quite possible that a system can be optimized, a system could be made robust, where all possible chances, all possible chances are worked out and eliminated, and simply finding out the best fit. Okay, that's what we call as process integration and design optimization. So this entire thing can be done perfectly using your generative AI. Okay, the methods of generative AI. Okay, so I would like to also uh, discuss something. I mean, a case study where we had worked on a gas turbine. We have worked on a gas turbine application that was in the year 2009, and that involved a lot of uh, processes. So there used to be a certain set of engineers and scientists from the defense research, okay, from the gas turbine establishment centers in India, where they were day in and day out. They were working on structural simulations analysis, and there used to be a team working on computation fluid dynamics. There used to be a team focusing only on to thermal aeroelasticity and thermal simulations, and there was a team that used to be focusing on acoustics. So complete design optimization process used to be a very tough task then at the point in 2008 and 9. So we had a system, a platform uh, where we were able to do, integrated simulation. That is multidisciplinary optimization, MDU. So using many algorithms, so genetic algorithm used to be one of the robust algorithms at that point of time, and today we call it as convolutional neural networks, CNN, GNN, ANN. So we have different algorithms today. So those days, that is in 2008 and 9, the algorithms were very, very, the typical algorithms, Latin hypercube, Monte Carlo. So these were all the optimization algorithms. Okay, and using that, we were able to do the complete optimization of the rotor blades and the stator blades. Okay, so now the actual gas turbine was imported from a certain country, and that imported gas turbine was dismantled, and the rotor blades and the stator blades were all reconstructed using reverse engineering process. The complete reconstruction of the blade was done, and the existing gas turbine were used for almost more than 25,000, 30,000 cycles. So that has considerably damaged the fins and the blades. Okay, so it was our duty to, in fact, derive the exact lift and drag coefficient, the pressure ratio. Okay, where the blades would give the maximum efficiency. So there, that was the first point where we, in fact, used generative AI. Okay, and that involved a lot of time. It involved a lot of parallel computation processes, and we had to use a supercomputer from the DRDO labs. And that's how we could make it possible within a span of about 6 months. So 6 months used to be the time actually for a certain process, which is drastically reduced using all the hardwares and software and the algorithms today. So something that we had done for 6 months, uh, I understand that today we can complete it probably within hours. Okay, and that's the robustness of using artificial intelligence in virtual, platform, and which can enhance your manufacturing processes, which can also enhance your production time. It can definitely reduce the production time, the cost to the time to the market, the launch of product to the market can be completely reduced. So any mechanical engineer or an aerospace engineer or any engineer, a chemical engineer, any engineer today need to definitely think about this particular transformation. Okay, and this transformation is very important as far as any designer is concerned, any product designer is concerned. See, uh, we cannot uh, we cannot say that a product becomes competitive only just because of the quality of material, the robustness of the uh, process, but also it depends on the kind of design process, the kind of design process. In the sense, uh, you know, there is a kind of sharpness involved in the engineering. It's not alone the technology that is going to help the engineer developing a product, but instead uh, the intuitive thought, okay, of an engineer definitely makes a change, a significant change. Okay, so let me just brief you about what we discussed today. So my first video tells about, it gives a basic introduction about our product development process. Okay, and how virtual simulation is going to help in product development. How and what were the kind of processes, and how there was a significant change or transformation in this product development process from the early 90s or 80s till the present year 2025. Okay, that used to be I mean that was the discussion that we had in the first video, and the second video uh, tells you about the significance of virtual manufacturing. Okay, digital manufacturing processes, digital twinning. So whatever you design and develop in your virtual CAD or CAE environment, okay, is tested. The prototype is tested using your test processes, and there is a correlation done between the CAD model, the virtual model, and your real-time model. And the CAD model is updated. There is some amount of updations done. There is a design, changes in the design parameters, which is adopted, and then the product is reiterated. And this optimized product is again checked, and there is a feel using virtual reality and using virtual simulation processes. And then the complete environment of the product is fed by an engineer. Okay, this helps in understanding more about the in-depth physics, not only the the structural, the mechanics part. It can even help you in understanding more about the vibrations, your NVH, your fatigue and damage tolerances. It can also help you in the aeroelastic behavior. It can also help you understand the optical parameters. Okay, like these many processes, these many significant activities are involved in the digital platform, manufacturing platform. Okay, so today let me just wind up here, and the next video I'm going to take a specific case, and I'm going to explain like where, at what stage, and what process, and what phase, what needs to be done, and how the process is taken care of. Okay, thank you. Thank you very much. So I am Praveen Ramachandran Nair, founder and the chief executive of Baba Civil Apps Private Limited, the company focusing on drone manufacturing, from agriculture, the surveillance, healthcare, the logistics, and manufacturing. So please feel free to send your comments, subscribe, and you can always share your ideas and thoughts. Thank you. Thank you very much.